So this is called the final common pathway, going from the neuron to the muscle. The muscle is sort of our effector. It's the thing that's doing things in the real world, right? So you have a muscle contraction. It starts with the alpha motor neurons releasing the acetylcholine. So exponential causes those acetylcholine vesicles to bind and release. Acetylcholine causes a whole bunch of EPSPs. Sorry, that's a voltage change caused by ions coming in through these channels. And then that actually evokes a muscle action potential, which triggers calcium inside the cell, which is the calcium that actually causes the actin myosin to start the contraction and ATP. And then the fiber contracts. And then you have to reuptake the calcium back into sort of a modified endoplasmic reticulum to stop the contraction. Or else the cells run out of energy and you go into rigor. There's a lot of feedback between, we always want to know where our muscle is, and so we actually have both muscle cells. We have two kinds of muscle cells. Ones are the ones that are actually causing the contraction, and then there's ones that actually are just for sensory. So we have the sensory neurons here, and they will measure how tight these muscles are contracting. And so you will actually adjust the contraction of these muscles to keep them so that they're about the same length. They sort of say this is the expected length of this muscle. And then if suddenly that muscle gets longer or shorter, then it will send a signal to the brain to then cause all the rest of the muscle to contract. Or not to the brain, to the spinal cord. So you will see things like here is we're measuring, like on your leg here, you suddenly put on a weight, which then suddenly makes your leg move down, which causes your muscle to lengthen. So it lengthens the muscle, and then that causes these neurons in these these spindles to start firing like crazy, which then sends a signal up to the spinal cord, which causes the muscle legs to contract, and actually on the other side to relax. And then it restores the leg back to the desired angle. And that's what you're testing when you put in it hit on your knee. It causes those neurons to fire really quickly, and then that causes that contraction. And because there's nothing on your leg, it causes you to kick. So here are those two types of fibers. So the extrafusal fibers, these are the ones that actually cause the contraction. These are innervated by the alpha motor neurons. And then you have the intrafusal fibers, which are innervated by the gamma motor neurons, which are the ones for maintaining that sensory organ within the muscle to make sure you're at the right length. So here's an example. Here's a muscle. These neurons are wrapped around here. They're causing a firing. Suddenly this muscle shortens. That causes these guys to suddenly stop firing because they're not receiving that signal, that input. So then what they do is, so that signal then causes these guys to start firing, which then causes the contraction. So when this contracts, these guys will start firing, which will contract the intrafusal fiber to the same length as the muscle. And then you have also sensory organs which are down in the tendon, which is really more of a strain gauge. These guys are measuring how much force is that muscle producing. And so these guys, because they're constantly adapting, can't tell you that. But these guys will tell you, hey, here we're not stimulating, and now we're stimulating these guys, is producing a lot of force, and that now causes these guys to go up, even though these guys don't change because it's an isometric contraction. But because you're producing force, you see these guys in the Golgi tendon start to fire.